Welcome to doassignment-ca. Here is the problem. The velocity time graph for a car moving along a straight road is defined as follows. Velocity equals 0.6 t squared for t between 0 and 5 seconds, and a straight line dropping from v equals 15 meters per second at t equals 5 seconds, down to v equals 0 at t equals 15 seconds. At time t equals 0, the position s equals 0. Part 1. Determine s as a function of t and a as a function of t for each interval. Part 2. Find the average speed and total distance traveled over the full 15-second interval. Now let's work through the solution step by step. First, we identify the velocity function in each time interval. From 0 to 5 seconds, velocity equals 0.6 t squared as labeled on the graph. From 5 to 15 seconds, the graph is a straight line dropping from 15 meters per second down to 0. The slope is 0 minus 15 divided by 15 minus 5, which equals negative 1.5. Using point slope form, we get velocity equals 30 minus 1.5 t. Acceleration is the derivative of velocity with respect to time. In the first interval, differentiating 0.6 t squared gives 1.2 t, a linearly increasing acceleration, rising from 0 at t equals 0 up to 6 meters per second squared at t equals 5 seconds. In the second interval, differentiating 30 minus 1.5 t gives a constant negative 1.5 meters per second squared. There is a sharp jump in acceleration at t equals 5 seconds, from positive 6 down to negative 1.5. To find the position function, we integrate velocity. In the first interval, integrating 0.6 t squared from 0 to t gives 0.2 t cubed. At t equals 5 seconds, the car has traveled 25 meters. This value becomes the initial condition for the next interval. For the second interval, we integrate 30 minus 1.5 tau from 5 to t, starting from s equals 25 meters. Evaluating the antiderivative 30 tau minus 0.75 tau squared between the limits 5 and t, we get the expression shown on screen, which we now simplify. Combining the constants 25 minus 1 or 31.25 gives negative 106.25, so position in the second interval equals negative 0.75 t squared plus 30t minus 106.25 meters. Plugging in t equals 15 seconds, negative 0.75 times 225 plus 30 times 15 minus 106.25 equals negative 168.75 plus 450 minus 106.25, which equals 175 meters. We must check whether the car ever reverses direction, because if it does, total distance and net displacement would differ. In interval 1, velocity 0.6 t squared is always non-negative. In interval 2, velocity equals 0 only at t equals 20 seconds, which is outside our window. The car simply comes to rest at t equals 15 seconds without reversing, so total distance equals net displacement, 175 meters. Average speed is total distance divided by total elapsed time. Dividing 175 meters by 15 seconds gives approximately 11.67 meters per second. Here is the complete summary. Position equals 0.2 t cubed for the first interval and negative 0.75 t squared plus 30t minus 106.25 for the second. Acceleration equals 1.2 t in the first interval and negative 1.5 meters per second squared in the second. The total distance traveled over 15 seconds is 175 meters, and the average speed is approximately 11.67 meters per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.